Okay. Hello, everybody. At the beginning, I wish you all a very nice and beautiful day. In this lecture, I am going to discuss with you several labVIEW virtual instruments related to the subject of image management and manipulations of images. I will begin with one of them. Excuse me, I will begin with another file. With this virtual instrument. Yes. This virtual instrument is about the motion of the display control on the front panel. You know, you can do that by hand. And it is possible to displace the whole image to the right or to the left, upwards or downwards, upon request. And also it is possible to do that at different steps. I mean, moving could be realized very quickly or slowly at specific steps, to the right or to the left or up or down. Here I am suggesting this block diagram, which includes, as you see, a while loop and a two-state case. The case is activated by a Boolean. When it is true, the true case works. When it is false, the false case works. At the beginning, of course, we should import or create an image. So we have IMAQ create to have a buffer for the image, and we have an image here displayed as a result of using the read function, IMAQ read file 2, which is used for this purpose. So the image is here now, and it is displayed, it should be displayed on the front panel here. When I run the program, for example, I have the display control stationary, and when I press the Boolean, of course, it should run at first, and you run the Boolean. Sorry. Oh, I have forgotten to tell you also that the while loop here, I especially made it so that it can run only 5 iterations, so that the displacement become limited. Let me do it, keep it to 10 or 20 so that you can see it. Otherwise, you may not notice it. So also, we have a timer here. As you see, 500 milliseconds it takes to make delay. And we have the two states. If you press here, you go to the second state, block diagram, or the first one will be the true state. There is no difference between both, except that here you use subtract function, the other one you use add function. The structure of both is the same. The virtual instrument is based on using the, let me show you. When I click the image and go to create, I go to property node and create a position. IMAQ control position here, and I create the IMAQ control position as usual from here, from position. Where is the position? Here is the IMAQ area. I can go there to the position and, select the position, all elements, for example. Okay, you can put it for elements. You can here change it upon request. So I did the things here to display the position through the node. Okay. So when you run the program here, you can stop it by pressing the stop push button, or by stop abort, or by using the abort knob here. If you press this knob and run the program, it will move in a direction, as you see, from right to left. If you stop it, it will move from left to right. Again, it has stopped because it is running more than 20 times. Now, within 20 iterations, I can manipulate it the way I like until it reaches the counter least 20, then it stops, of course. Now it stopped. Also, I can manage it to move upwards or upward to the left, to the right, depending on the configuration which I like. For example, if I put here instead of left, if I select the top and I select here the top and I run the program, now it is going down. If I stop it, now it is going left. I stop it, it is going down. So it depends on what direction you want. The program could be configured or reconfigured upon request. This is sometimes necessary to position the display control in the correct place at the given precise place by using the required step. Here required is taken 10. I can make it very smooth. I can put it 1 here. And now, as you see, when I run the program, it will move, but with smaller increments. As you see, it is moving with small increments to be positioned upon request. I can also, as I told you, stop it and run again and change the direction to the direction I want, and so on. Then I can stop it. Of course, this whole control could be moved by hand. As I told you, I can displace it as I want, but this program allows you to make that programmatically. Well, I think this is the target of this simple program, but I offer you to such programs to have experience and to gain experience more and more about using labVIEW programming in image processing. Okay, so we move to the next one. Don't save. Setting center position of the image. Sometimes the image is very large and it is displayed in the display control, not at a center position. And you require to position it correctly within the display control. Here is the program. Here we read an image from a file, and this is the file location, and this is the image which is going to be read. Before reading, of course, I will go here and through the property node, I can go to, yes, property node, I go to the image center position, for example. I want to the X position, maybe, I put it here. Image center X position, for example. I can also drag it and have it to the Y position if I want. Sorry. Why it is like I can go there and to the IMAQ center position and display the Y position. And now I have a Y, I have an X. Or here I can change it. So it depends what I want. I have fixed both here. Property node of the image. Here is the image. This is the property node. Image center X position. I converted it from read to write. And this is the same. And the two values which I have to input are through these two dials, or I can add them directly because I have created here also a digital position display. So if we import an image, let me go and show you, for example, how we do it. And we go to, for example, image like this one. I want it a little bit, okay. And when we play, we find that it is displayed and not centered. So as you see here, the forehead, I can see that the coordinates in this place here of the forehead is about 350 by 130. Let me fix it here. 350, and the Y is by 130. And now when I run the program, it is displaced in the center upon desire. So also, although this program is simple, but such techniques, you should know it. You will face it one day, and now you have an idea how to work with the property node of the image, of course, to create the variables you want. Okay. Let us move to another similar example. Resizing the image container. when we display the picture of labVIEW by using the labVIEW picture, as you see sometimes like this here is the frame and here is the picture. You need it to look nicely, and you need to resize or to have the display with a frame appropriate for the image, like this here. So you need to resize the image, and you need to do that also programmatically. So this is the program which helps to do that. Here, as you see, I told you that this picture which we have here is not an IMAQ image. As you see, it is a picture labVIEW picture. So here we have a read function which reads the file type JPEG. And now here we have the data which describes the picture. Of course, by using draw, this is the array is flattened here, as you see. It is one-dimensional array. So as you see here, we can draw it by using draw flattened pixmap, and we can get the image here. This image really is this one which we get initially. Now, when we go back, we go to the image here again and create a property node for it. We right-click it and go to create and to property node, as you see. And we have created draw area size from there. So what we have done, again, I am going to the image and create, and you go to the, create property node, draw area size, and we put it here, as it is done here. It is converted from write to read, and we connect to it two dimensions which represent the X and Y pixel values of the image. You remember, this is the image data. And if we put here unbundle function, as it is done here, but I will able to show you how it is. This is the values inside it, which is the image depth, image type, and at the end you have a value of the rectangle depth and rectangle. Here is the rectangle. The rectangle coordinates which you need to define the area of the image. Of course, I have taken the rectangles. I have taken the values which are of interest, which is the right bottom value of the rectangle, X and Y. So if this is the image, for example, this is the upper left values, and this is the lower right values of the rectangle. These values, this value represents the X and Y coordinates. So they are taken here, extracted by using the unbundle of this cluster. They are changed to constants without fractions, unsigned 32 bits, and both of them are bundled to the draw area size. Now, when you display the program, you will have two pictures or two outputs. The original, which is this one, which is not treated or resized, and the other one, which is resized. When I run, I have both. Of course, as I told you, I can minimize this by hand, but maybe this is not the ideal case, or maybe sometimes it is necessary to have it automatically. So, of course, this depends on the picture and its location. If I go to, for example, these apples, and I import the apples, also I will have the apples, but this now appeared because I have resized it. If I go, for example, let me show you to this flower and I run it. Here is telling me that the type of the file is different. Okay. The type is different. BMP, not JPEG. There I asked in the program to read a JPEG file. Here it is BMP type, so it doesn't work. I have to select one with JPEG or JPEG. So, like this one, JPG, it will work. So, as you see, the area is big, but here it is resized upon request as according to the coordinate which we introduced, which are the coordinates of course, X and Y for this original image. Well, as you see, the program of today are simple by structure, but they are really very useful to work with in life. The next one is convert an image to different image. Really, I have worked with you with similar example before, but I wanted to demonstrate it to you to show you also specific cases which we may face. So what do we have here? As you see, let me show you the program. This is the block diagram. And as you see, the block diagram reads an image by IMAQ read, and this is the output of the IMAQ read. But this is the output here. I have taken it outside and called it image2. This image2 is the read file, the image which we see as a result of reading the file. But this image now is introduced to IMAQ cast image, so that at the output here, I get the type of the image I want. How I decide the type of the image out and the output here, it is decided by using this input, image type. If I press it and go there, you have to select here the type you want to have at the output. Well, as you see here, the grayscale U8 is tagged here, and really at the output I have the original image which came from the file, and the output, let me show you, and the output here, which we have seen after the IMAQ cast image function. So again, if I run it, yes, I shall have a grayscale image, and I shall have the colored image. Suppose I want to see here not a grayscale image, a colored image. So I need here to specify for the cast function that I need RGB input. Here, now we have RGB image type, and the output here will be now colored as the input. So when I operate the program, I have two images, and both of them is colored. Here is an interesting thing I want to show you also today, which is clear errors VI. What it is and why. If we go to the file input output, well, I think it is in the file input output. Yes. And maybe in other file, yeah, and other files configurations, maybe in the file constants, file constants, not shown. So what I can do, easier to do, I right-click it and go to help, and now you will see where it is here. Clear errors VI, the owing palette, which means that the palette which includes this function is called dialog and user interface VIs and functions. I have to the dialog and user interface VIs and functions. Also, labVIEW gives you a facility to directly load this function to the block diagram you are working with. What you have to do is to press the plus here and put it here. Now it is there as I did. So you have many ways to manage that. Suppose it is here. What it is for? This is the most important. It is used here in order to override the error messages which we can receive as a result of some abnormal situation. So, clear errors VI resets the error status to no error, code 0, and source to an empty string. So, this means that if you receive a message telling you that there is an error in the program, and you include this function by either including the function or including the number of the error code here, your program will continue working and it ignores the error message. So let us see. Now, as I have said, suppose that we want to fix here the type of the image to be, for example, I or U16. Now, if I run the program, we get invalid image type. This is a message which is telling us that there is a problem. He is saying that there is an error code. This is the error code in labVIEW, which occurred at IMAQ write JPEG file. Okay. So the problem is here because this image is not received to be written. I can avoid this by introducing this clear error VI. All what I have to do here is to continue. Now I connected the program, the function. And now if I work again, I have an output grayscale image without an error message. Really, this is useful in life, and you might face it more than one time in your life. What else in this program? I think everything now is clear, and the image which is received here is written to a file, and this file is given here as in pictures, and it is called alia1. So if we go to the pictures, sorry, here, from here we can go, oh, here in pictures, and you go to file alia1, it was called alia1 somewhere, I am not sure of it. Let us see. It is not that important, but just to be sure, this is the pictures, right? Yeah, it seems no. This is alia. Where it is. Is there a problem with the address? Okay, let me go back to the image. This is not our. Let us go to the image back to where can I go? I can go here to the PC, to the desktop, labVIEW images, labVIEW image processing, and then I move to the training course, which we have here, ST training course. And now I'm working at image manipulations, as I remember, or not. Did I work with colors? Maybe with colors there. Yes, here I am. Setting center, create image data from read one directional shift, create color image using color. Okay, well, let me go back. Maybe the easiest way to go to the recent. Here it is. So what is the, maybe, okay, here let me put it correctly now to U8, for example, and now without error, now it is gray. If I put it RGB 32, it should work and be there, okay. Now if I go to pictures, early one, here is pictures. Here is now appeared. Here is early one. If I open it by paint, for example, it is there. So everything is okay. We have no problems. There is no problems. Okay, so we have discussed the program with setting center position and two directional motion, and now let me go to the folder. It seems that I have forgotten the folder where I put the okay, this must be also created, must be cleaned. Okay, I'm sorry. And okay, now I go to desktop, LabVIEW image processing, and to the training course. ST, RST, where it is now. Pictures and images should be here. And now we have stopped here, convert LabVIEW image to image type, to any image type. Okay, we have done this and we finished with this program. Now we will move to this program. Here is the block diagram. And as you see, we have also gone through similar examples, but it is also but this program also has its specifics. So we are reading a file by using JPEG function, and by using this is, as you see, this strip here shows that the array is one-dimensional. I mean, it is flattened, and so we can use draw flatten pixmap. And here is the picture. So we are drawing the picture, and we have the picture here. But this picture, as you see, is not IMAQ picture. It is not IMAQ picture. It is a labVIEW picture. Here it is. Now, as usual, this is the picture here. From the picture, we can take the picture data, picture to pixmap view. This is the picture data. And now from picture data, we get the two-dimensional array of the picture. If we display it, it is here. This is the two-dimensional array of the picture. This two-dimensional array now is fed to the converter from array to color image. So we get as the output an image here, but the difference between this image and this picture here is this is an IMAQ data type, while this is here a labVIEW data type. They are different in their structure internally. This operation is really the inverse of one operation I have shown you before when we converted the IMAQ image to a labVIEW picture. What is interesting also in this program here, as you see, here in the error line, we have, as you see, introduced, let me put this function here. we have introduced a sequence structure with a timer inside it. This timer helps to keep the image as the output, this image, for this given time, and then it disappears. So if we run the program, now the program is running, we have at the input and we have the output. But this output should appear after the elapse of the time I have given. It doesn't go, it is still there. Why it is still there? Because this function, I am sorry, this is another program here. We're working with this one. Because this function here is not connected to the image. If I connect this with the image, now look what we may have. I first want to get out of this program. I have finished with it. Yes. And now, if we run this program again, it is running for the definite time, which is there in the sequence structure. And as I suppose this now, this fan doesn't exist. It is finished. It is. So the interesting thing there, again, is that by introducing the required time here, you can keep the image staying, and you can see it, and you can work with it as you want, and then it finishes and elapses. Otherwise, if you wanted to stay stationary, you can only cancel this function, which removes, sorry, let me put its name, which disposes the image. And now if I run the program, the image will stay for the time, anytime while the program is going on, it will be there. There is no problem with it. It will stay there. So this facility also is very useful to use, and you can select between both cases, either to display the image constantly and to keep it under your eyes, or to keep it for a while, for a piece of time, interval of time, and then it vanishes automatically. The last program I want to work with you today is also this one here. Let us show the program, the block diagram. Is there something interesting here also? Let us see. So this is the input. This is the file address, the read function, and now we have the image. So we have read an image here. This is the image. Okay, when we go, we find that the image as the output is input to a converter which converts the image to a two-dimensional array. Now, this, as you see, function gives you at the output here a one-dimensional array, and then you can use the draw flattened image and get the picture here. So we have, as you see, converted the image of labVIEW of IMAQ, of IMAQ, to a picture of labVIEW. And we can do the inverse. We can take the image, the picture of labVIEW now, and convert the picture to a data set. And now we can write the image to a given file and read it from there upon request. Also here, as you see, the image which we get could be stationary for a given time and could be constantly fixed on the display. So here, while doing this configuration or while applying this configuration, the image will stay only for 20 seconds and then it will disappear. So if we run the program, as you see, it is a long time. It has disappeared, as you see. If I want to keep the image continuously, I have to open this path. And now, when I run the program again, I will have the image, but this image will stay as the program is running. So today we have discussed with you about 5 or 6 small programs. Each of these programs has its applications at its merits. And I hope that these things will help you to improve your skills in working with LabVIEW programming and image processing. In the next lecture, we will begin a new chapter, a new aspect related to imaging, which is the audio-visual interleave images. Audio-visual images are used intensively in life and in engineering practice also. So we will learn how we can manage them also through specific examples. Well, up to the next lecture, I wish you all the best and goodbye.